Hello everyone. Chapter number 9, Atmospheric Circulation and Weather System. Earlier, chapter 8 described the uneven distribution of temperature over the surface of Earth. Air expands when heated and gets compressed when cooled. This results in variation in the atmospheric pressure. The result is that is cause the movements of air from high pressure to low pressure, setting the air in motion. You already know that air in horizontal motion is wind. Atmospheric pressure also determine when the air will rise or sink. The wind redistributes the heat and moisture across the planet, thereby maintaining a constant temperature for the planet as a whole. The vertical rising of moist air cools it down from the clouds and bring precipitation. This chapter has been devoted to explain the cause of pressure difference, the forces that control the atmospheric circulation, the turbulent pattern of wind, the formation of air masses, the distributed weather when air masses interact with each other, and the phenomena of violent tropical storm. Atmospheric pressure. Do you realize that our body is subjected to a lot of air pressure? As one moves up the air gets rarefied and one feels breathless. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmospheric is called atmospheric pressure. The atmospheric pressure is expressed in unit of millibar. At sea level, the average atmospheric pressure is 1013.2 millibar. Due to gravity, the air at the surface is denser and hence has higher pressure. Air pressure is measured with the help of a mercury barometer or the Android barometer. Consult your book Practical Work in Geography and learn about these instruments. The pressure decreases with height. At any elevation, it varies from place to place, and its variation is the primary cause of air motion. That is, wind which moves from high pressure area to low pressure areas. Vertical variation of pressure. In the lower atmosphere, the pressure decreases rapidly with height. The decrease amount to about 1 millibar from each 10-meter increase in elevation. It doesn't always decrease at the same rate. Table 9.1 gives the average pressure and the temperature at selected levels of elevation for a standard atmosphere. The vertical pressure gradient force is much larger than the that of the horizontal pressure gradient, but is generally balanced by a nearly equal but opposite gravitational force. Hence, we do not experience strong upward winds. Horizontal distribution of pressure. Small differences in pressure are highly significant in terms of wind direction and velocity. Horizontal distribution of pressure is study by drawing isobar at constant level. Isobar are lines connecting places having equal pressure. In order to eliminate the effect of altitude on pressure, it is measured at any station after being reduced the sea level for purpose of comprehension. The sea level pressure distribution is shown on weather maps. Figure 9.1 shows the pattern of isobar corresponding to pressure system. Low pressure system is enclosed by one or more isobar with the lowest pressure in the center. High pressure system is also enclosed by one or more isobar with the highest pressure in the center. World distribution of sea level pressure. The world distribution of sea level pressure in January and July has been shown in figure 9.2 and 9.3. Near the equator, the sea level pressure is low and the area is known as equatorial low. Along 30° north and 30° south are found the high pressure are known as the subtropical high. Further polewards along 60° north and 60° south, the low pressure belts are termed as the subpolar lows. Near the poles, the pressure is high and it is known as the polar high. These pressure belts are not permanent in nature. They oscillate with the apparent movement of the sun. In the northern hemisphere, in winter they move southwards and in the summer northernwards. Forces affecting the velocity and direction of wind. You already know that the air is set in motion due to the difference in atmospheric pressure. The air in motion is called wind. The wind blows from high pressure to low pressure. The wind at the surface experiences friction. In addition, rotation of the earth also affects the wind movement. The force excreted by the rotation of earth is known as the Coriolis force. Thus the horizontal winds near the earth's surface respond to the combined effect of three forces: the pressure gradient force, the frictional force, and the Coriolis force. In addition, the gravitational force acts downward. First, pressure gradient force. The difference in atmospheric pressure produces a force. The rate of change of pressure with respect to distance is the pressure gradient. The pressure gradient is strong where the isobar are close to each other and is weak where the isobar are apart. Second, frictional force. It affects the speed of wind. It is greatest at the surface and its influence generally extends up to an elevation of 1 to 3 km. Over the sea surface, the friction is minimal. Third, Coriolis force. The rotation of the Earth about its axis affects the direction of the wind. The force is called Coriolis force after the French physicist who described it in 1844. It deflects the wind to right direction in the northern hemisphere and the left direction in southern hemisphere. The deflection is more when the wind velocity is high. The Coriolis force is directly proportional to the angle of latitude. It is maximum at the poles and it is absent at the equator. The Coriolis force acts perpendicular to the pressure gradient force. The pressure gradient force is perpendicular to an isobars. The higher the pressure gradient force, the more is the velocity of the wind and the larger is the deflection in the direction of wind. As a result of these two forces operating perpendicular to each other, in the low pressure areas the wind blows around it. At the equator, the Coriolis force is zero and the wind blows perpendicular to the isobar. The low pressure gets filled instead of getting instantified. That is the reason why tropical cyclones are not formed near the equator. Second, pressure and wind. The velocity and direction of the wind are the net result of the wind generating force. The wind in the upper atmosphere 2 to 3 km above the surface are free from frictional effect of the surface and are controlled mainly by the pressure gradient and the Coriolis force. When isobars are stiff and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is known geotrophic wind. It means are in northern hemisphere and southern hemisphere the pressure gradient force is balanced with the help of Coriolis force because the isobars are stiff. So this wind is known geotrophic wind. The wind circulation around a low is called cyclonic circulation. Around a high it is called anticyclone circulation. The direction of wind around such system change according to their location in the different hemisphere. The wind circulation at the Earth's surface around low and high on many occasions is closely related to the wind circulation at the higher level. Generally, over low pressure area the air will converge and rise. Over high pressure area the air will subside from above and diverge at the surface. Apart from convergence, some eddies, convection current, orographic uplift and uplift along fronts causes the rising of air, which is essential for the formation of the cloud and precipitation. Divergence and convergence. Next topic, general circulation of the atmosphere. The pattern of the planetary winds largely depends on first, latitudinal variation of atmospheric heating, second, emergence of pressure belts, third, the migration of belts following a patterned path of the sun, and fourth, the distribution of continents and ocean, and fifth, rotation of Earth. First, latitudinal variation. Second, emergence of pressure belt. Third, migration of belts. And fourth, distribution, continent and ocean. And fifth, rotation of Earth. The pattern of the movement of the planetary winds is called the general circulation of the atmosphere. The general circulation of the atmosphere also sets in motion the ocean-water circulation, which influence the Earth's climate. A schematic description of the general circulation is shown in Figure 9.6. It means equator lines ITCZ, then downward southern hemisphere and upward northern hemisphere. The air at the Intertropical Convergence Zone (ITCZ) Intertropical Convergence Zone rises because of convection caused by high insolation and a low pressure is created. The winds from the tropic convergence at this low pressure zone. The converged air rising along with the connective cells. It reaches the top of the troposphere up to an latitude of 14 km and moves towards the pole. This causes accumulation of air at about 30° north and 30° south. Part of the accumulated air sink to the ground and form a subtropical high. Another reason Another reason for sinking is the cooling of air when it reaches 30° north and 30° south latitudes, called name is subtropical. Down below, near the land surface, the air flows towards the equator as the easterlies. The easterlies from either side of the equator converge in the Intertropical Convergence Zone, it means ITCZ, such that circulation from the surface upwards and vice versa are called sails. Such a sail in the tropic is called Hadley sails. In the middle latitude, the circulation is that of the sinking cold air that comes from the pole and the rising warm air that blow from the subtropical height. At the surface, these winds are called westerlies, and the sail is known Ferrel sail. At polar latitude, the cold, dense air subsides near the poles and below towards middle latitude as polar easterlies. This cell called the polar cell. These three cells set the pattern for the general circulation of the atmosphere. The transfer of heat energy from lower latitude to higher latitude maintains the general circulation. The general circulation of the atmospheric also affects the ocean. The large-scale winds of the atmospheric initiate large and slow-moving current of the ocean. Ocean in turn provide input of energy and water vapor into the air. These interactions take place rather slowly over a large part of the ocean. General atmospheric circulation and its effect on ocean. Warming and cooling of the Pacific Ocean is most important in terms of general atmospheric circulation. The warm water of the central Pacific Ocean slowly drifts towards South American coast and the places the cool Prevenient current. Such appearance of warm water off the coast of Peru is known as the El Nino. El Nino. The El Nino event is closely associated with the pressure change in the Central Pacific and the Australia. This change in pressure condition over Pacific is known as the Southern Oscillation. The combined phenomena of the Southern Oscillation and El Nino is known ENSO. In the year when the ENSO is strong, large-scale variation in weather occur over the world. The arid west coast of the South America receive heavily rainfall. Drought occurs in Australia and sometime in India and flood in China. This phenomena is closely monitored and it used for long-range forecasting in major part of the world. So this is very dangerous causes for the world. Seasonal wind. The pattern of the wind circulation is modified in different seasons due to shifting of region of maximum heating pressure and wind belts. The most pronounced effect of such a shift is noticed in the monsoon, especially over the Southeast Asia. You would be studying the details of monsoon in the book India Physical Environment. The other local deviation from the general circulation system are as follows. This is seasonal winds at the time of monsoon. Second is local winds. Difference in the heating and cooling of the earth surface and the cycle those develop daily or annually can create several common local or regional winds. Sea and land and sea breezes. As explained earlier, the land and sea absorb and transfer heat differently. During the day, the land heats up faster and become warmer than sea. Therefore, over the land, the air rises, giving rise to a low pressure air, whereas the sea is relatively cool and the pressure over sea is relatively high. Thus, pressure gradient from sea to land is created and the wind blows from the sea to the land as the sea breeze. It means from the land, so land breeze, from the sea to sea breeze. In the night, the reversal of the condition takes place. The land loses heat faster and is cooler than the sea. The pressure gradient is from that the land to the sea and hence land breeze result. This show land breeze and sea breeze. Mountain and valley winds. In mountains region, during the day, the slope gets heated up and air moves upslope and to fill the result gap, the air from the valley blows the valley. This wind is known as the valley breeze. During the night, the slope gets cooled and dense air descends into the valley as the mountain wind. The cool air of the high plateaus and ice field draining into the valley is called Kadiabatic wind. It means mountain wind, also called Kadiabatic wind. Another type of warm wind occurs on the leeward side of the mountain ranges. Leeward side, it means not happen any rain without raining part of areas. The moisture in these wind while crossing the mountain ranges condense and precipitate. When it descends down the leeward side of the slope, the dry air gets warm up the adiabatic process. This dry air may melt the snow in short time. Air masses: when the air remains over the homogeneous areas from a sufficiently longer time, it acquires the characteristics of the area. The homogeneous regions can be the vast ocean surface or vast plain. The air with distinct characteristics in terms of temperature and humidity is called an air mass. It is defined as a large body of air having little horizontal variation in temperature and moisture. The homogeneous surface over which masses form are called the source region. The air masses are classified according to the source region. There are five major source regions. These are: first, warm tropical and subtropical oceans; second, the subtropical hot desert; and third, the relatively cool high latitude ocean; and fourth, the very cold snow-covered continent in high latitudes; and fifth, permanently ice-covered continents in the Arctic and Antarctic. Permanently. According following types of air masses are recognized. First, maritime tropical, it means empty. Continental tropic, it means CT. Maritime polar, it means MP, and continental polar, it means CP. Continental Arctic Ca, tropical air masses are warm and polar air rise are cold. Fronts. Front scale. When two different air masses meet, the boundary zone between them is called front. The process of formation of the fronts is known as frontogenesis. Frontogenesis. There are four types of fronts called warm, stationary, and occultated. When the front remains stationary, it is called a stationary front. It means no movement. When the cold air moves towards the warm air, its connect zone is called the cold front. Whereas if the warm air mass moves towards the cold air mass, the contact zone is the warm front. If an air mass is fully lifted above the land surface is called occultated front. The front occur in the middle latitude and are characterized by steep gradient and temperature and pressure. They bring abrupt change in temperature and cause the air to rise to from cloud and causes precipitation. Extra tropical cyclones. The system developing in the mid and high latitude beyond the tropic and called the middle latitude or extratropical cyclone. The passage of front causes abrupt change in the weather condition over the areas in the middle and high latitude. Extratropical cyclone from along the polar front. Initially, the front is stationary in the northern hemisphere. Warm air blows from the south and cold air from the northern of the front. When the pressure drops along the front, the warm air moves northernward and cold air moves towards south, sitting in the motion and anti-clockwise cyclone circulation. The cyclonic circulation leads to well-developed extratropical cyclone with a warm front and a cold front. The plane and cross section of a well-developed cyclone is given in Figure 9.9. There are pockets of warm air or warm sector wedged between the forward and the rear cold air or cold sector. The warm air glides over the cold air and a sequence of the cloud appear over the sky ahead of the warm front and cause precipitation. The cold front approaches the warm air from behind and pushes the warm air up. As a result, cumulus clouds develop along the cold front. The cold front moves faster than the warm front, ultimately overtaking the warm front. The warm air is completely lifted up and the front is occluded and the cyclone dissipates. The process of wind circulation, both the surface and aloft, are closely interlinked. The extratropical cyclone differs from the tropical cyclones in numbers of waves. The extratropical cyclones have a clear front, frontal system, which is not present in the tropical cyclone. They cover a large area and can originate over the land and sea, where the tropical cyclone originate only over the sea and on reaching the land they dissipate. The extratropical cyclone affected a much larger area as the compared to tropical cyclone. The wind velocity in a tropical cyclone is much higher and it's more destructive. The extratropical cyclone move from west to east, but tropical cyclone move from east to west. It means direction is very different. Tropical cyclone. Tropical cyclones are violent storms that originate over ocean in tropical areas and move over to the coastal areas, bringing about large-scale destruction caused by violent winds. Very heavy rainfall and storm surge. This is the one of the most devastating natural calamities. They are known as cyclones in the Indian Ocean, hurricanes in the Atlantic, cyclone in Indian Ocean, hurricanes in Atlantic, and typhoon in Western Pacific and South China Sea, and Billy Willies in the Western Australia. The tropical cyclones originate and intensify over warm tropical ocean. The conditions favorable for the formation and the intensification of tropical storm. First, large sea surface with temperature higher than 27 degrees Celsius. Second, presence of the Coriolis force. Third, small variation in the vertical wind speed. And fourth, a pre-existing weak low pressure area or low level cyclone circulation. And fifth, upper divergence above the sea level system. The energy that intensify the storms comes from the condensation process in the touring um, gloomy uh, cumulonimbus cloud surrounding the center of the storm, which continues supply the moisture from the sea. The storm is further strengthened. On the reaching the land, the moisture apply is cut off and the storm dissipates. The place where a tropical cyclone across the coast is called the landfall of the cyclone. The cyclone, which cross 20° north latitude, generally recur and they are more destructive. A systematic representation of the vertical structure of the mature tropical cyclone storm is shown in Figure 9.10. A mature tropical cyclone is characterized by the strong spiritual circulating wind around the center, called the eye. The diameter of the circulating system can vary between 150 and 250 km. The eye is a region of calm with subsiding air. Around the eye is the eye wall, where there is a strong spiraling ascent of the air to greater height reaching the tropopause. The wind reaches maximum velocity in this region, reaching as the high as 250 km per hour. Torrential rains occurs here. From the eye wall, rain band vary, radiating and trends of cumulus and cumulonimbus clouds may drift into the outer region. The diameter of the storms over the Bay of Bengal, Arabian Sea, and the Indian Ocean is between 600 to 1200 km. The system moves slowly, about 300 to 500 km per day. The cyclone creates storm surges and they inundate the coastal lowlands and the storm peters out on the land. Thunderstorms and tornadoes. Other South local storms are thunderstorms and tornadoes. They are a short duration, occurring over a small area, but are violent. Thunderstorms are caused by intense convection on moist hot days. A thunderstorm is a well-grown cumulonimbus cloud providing thunders and lightning. When the cloud extends to height where sub-zero temperature prevails, hails are formed and they come down as a hailstorm. If there is insufficient moisture, a thunderstorm can generate dust storm. A thunderstorm is characterized by intense updraft of rising warm air, which cause the cloud to grow bigger and rise to greater height. This causes precipitation. Later downdraft bring down to earth the cool air and the rain. From south thunderstorms sometimes spiraling wind descend like a trunk of an elephant with great force, with very low pressure at the center, causing massive destruction on its way. Such as a phenomena is called a tornado. Tornadoes generally occur in middle latitudes. The tornado over the sea is called water spouts. These violent storms are manifestation of the atmospheric adjustment to varying energy distribution. The potential and the heat energy are converted into kinetic energy in these storms and these restless atmosphere again return to its stable state.